All right, so now we have a bunch of points on the terminal arm of an angle theta. First we're going to draw it, then find sine, cosine, tangent, and then use one of those to find theta, but we're also going to use the picture to find theta. So let's start with A. That's the point 2, 5, so over 2, up 5. There's my point. I'm going to label this one A. So I'm going to draw the terminal arm. Here's my initial arm. So theta is down here between the terminal arm and the x-axis. I know this length is 2, this length is 5 because I'm at the point 2, 5. Pythagorean theorem tells me that the hypotenuse is going to be the square root of 29. So I can find all of my ratios. So sine of this angle is 5 over root 29, which we could rationalize, 5 root 29 over 29. Cosine is 2 over root 29, and I'm going to leave it. I know it's not particularly pretty, but I'm going to leave it that way. And tangent is opposite over adjacent. I can pick any one of these to find my theta. And I'm just going to slide this hypotenuse out of the way so I have a little bit more room. So for all of these are 2, 5. So for all of them, the hypotenuse is going to be root 25. Positive, negative doesn't matter because of the squaring in the Pythagorean theorem. Okay, so I can use any of these to find theta. And I'm actually going to call this theta A because this is my angle for problem A. So theta A, I'm just going to say is sine inverse of 5 over root 29. And that's about, let's see here, make sure of our mode. Yes, we're in degrees. So sine inverse 5 over root 29. (68.2 degrees, that looks about right. Right. So because all of these are 2, 5, but in different quadrants, this theta A is going to become my reference angle. I'm going to show you what I mean. So I'm going to switch over to blue for problem B. And now I'm going to draw a negative 2, 5. So negative 2, 5 is here. So when I think about my angle B is going to be from the x-axis on the positive side over to the terminal arm. But notice that this triangle here is similar to this triangle. That means this reference angle here is going to be the same size as theta A. So right now, I could say that my theta B is going to be 180 minus theta A without even having to do any of my sine cosine calculation. Because this size is theta A, so 180 to here minus theta A gives me my theta B value. Since I'm in quadrant 2, I know it has to be between 90 and 180 degrees. So let's go calculate theta B. So 180 minus that answer, 111.8. And now let's go and look at what our calculator would have said with our different ratios. So for my x value, that's negative 2. My y value is positive 5. So in this case, sine of theta B is going to be 5 over root 29 again. So exactly the same as this one. Let's go and look at that. So sine of this first angle sine of this second angle (5 over root 29). All three of those are the same value. They're all equal to each other. So if we had tried to solve for theta now, if we had done sine inverse of 5 over root 29, our calculator would have told us this value. Because we drew the picture, we knew that theta b was actually bigger than 90. So we had to do the 180 minus theta a. So we couldn't have used our calculator to find the angle in quadrant 2 with the sine ratio. Let's look at the cosine ratio. Cosine of theta b is negative 2 over root 29. So in this second quadrant, I have a negative cosine value. Let's try that in our calculator. So cosine inverse of negative 2 over root 29. That gave us our 111.8 degrees, so I could have used that as well. Tan theta b, 5 over negative 2. The negative can go top, bottom, out in front, doesn't matter. If I tried this one on my calculator, tan inverse, negative 5 over 2, negative 68. Notice I got this angle, but the negative side. So I think it's far easier to use the reference angle and not worry about which ratio to use to get the correct value from your calculator. Using my reference angle, 180 minus the angle. So I'm going to stop there. I want you to try these last two examples. You can go online to find the solutions and think about your reference angles to find the angles. I would say that for angle C and angle D, let's use a different color, and angle D, you don't even need to use your use your calculator to do the subtractions, additions, but you don't need to use sine or cosine or tan inverse to find those angles.